Picture this. A car rolls off a factory line in central China, looking completely normal from every angle. It drives normal, parks normal, and you could set it right next to a Tesla without spotting a single difference. But pop open the hood and look at the battery, and something does not add up. Because that battery holds no lithium in it, not a single trace. The most important material in every phone, every laptop, and every electric car on the planet. The stuff that countries are lining up to fight over, the stuff that costs a fortune to rip out of the ground, is simply not there. Instead, this battery runs on something you already have sitting in your kitchen cabinet, something so cheap it barely carries a price tag. When engineers at the US Department of Energy reviewed what this battery could do, the room went quiet. And the reason is simple. If this works at the scale China claims, and early signs suggest it already does, then America faces a problem it did not see coming. By the end of this video, you are going to understand exactly why. Here is why this matters to you right now. Every battery you touch today, the one in your phone, the one in your laptop, the one keeping the lights on when the power cuts out, they all depend on lithium. And lithium is not cheap. When the price of lithium climbs, the price of electric cars climbs right behind it. The cost of storing solar energy jumps with it, and your electricity bill feels every bit of that pressure. You notice it at the car dealership, you notice it in your monthly power bill, and the entire push to move away from fossil fuels slows down because one single material got more expensive. And here's the part most people never hear about. Almost all of the world's lithium supply comes from just 3 countries, which are Australia, Chile, and China. If you are America or Europe or India, and you want to build millions of electric cars, you are depending on someone else for the single most expensive part. That is a weak spot, and China just figured out how to make that weak spot completely irrelevant, not just for themselves, but for everybody watching. Hit subscribe and stay with me, because what I'm about to walk you through will change how you think about energy, about cars, and about who actually holds the power over the next 20 years. Before any of this makes sense, you need to understand one thing about how a battery actually works, and I promise this is far simpler than it sounds. A battery is just a box with 2 sides. One side holds a material that wants to push tiny charged particles out, and the other side holds a material that wants to pull those particles in. When you connect the 2 sides with a wire, those particles flow through it, and that flow of particles is electricity. That is what keeps your phone alive every day, just tiny particles moving from one end of a box to the other through a wire. For the last 30 years, the best particle for this job has been lithium. Lithium is a metal, it is extremely light, and its particles move fast, which is why lithium batteries pack so much energy into a small space without weighing much. They charge quickly, they last a long time, and they are the reason your phone survives from morning to midnight instead of dying by lunch. Every phone company picked lithium, every car company picked lithium, and every power company built their entire system around that one material. Factories were designed for it, shipping routes were mapped for it, and billions of dollars poured into mines built specifically to pull it out of the ground. And that worked fine for a while, but here's the thing. There is not enough lithium on the planet for what the world wants to do next. Right now, every country on Earth is racing to go green at the same time. America wants millions of electric cars on the road. Europe wants to store wind and solar power in giant battery banks. India wants fleets of electric buses, and Africa wants access to cheap, clean energy. All of them need batteries, mountains of batteries, and all of those batteries need lithium. But here's the thing. Getting lithium out of the ground is painfully slow. Opening a new mine takes years. It burns through massive amounts of water, and it tears apart the surrounding land. Even if you somehow sped all of that up, the math still does not work, because there simply is not enough lithium in the Earth's crust to power everything everyone wants to build. Not at the speed they want to build it. And that is when the price went haywire. In 2022, the price of lithium exploded by more than 10 times in under a year. And that one spike alone added thousands of dollars to the sticker price of every electric car on the market. People who were ready to buy an electric vehicle walked into the dealership, saw the new price tag, and walked right back out. And that is the trap the whole world fell into. The world needs batteries to go green, but the material those batteries depend on is rare, expensive, and controlled by a handful of countries. It is like trying to build a highway system when only 3 countries on Earth sell concrete. Which is why a group of very smart engineers started asking a completely different kind of question. What if we just stopped needing lithium altogether? And what if there was something else out there? Something cheap, something common, something that every country on Earth could get its hands on without asking anyone for permission? And the answer they kept landing on was so simple, so obvious, that for years nobody took it seriously. I want you to remember one word, and that word is sodium. Burn it into your brain because it keeps showing up again and again as this story unfolds. Sodium is the stuff inside salt, the same table salt sitting on your dinner table right now, the salt on your fries, the salt dissolved in every ocean on the planet. It is one of the most common materials on Earth, and you could not run out of it even if you tried. The entire planet is covered in the stuff. And here's the key that makes this matter. Sodium and lithium are chemical cousins, sitting right next to each other on the periodic table, behaving in almost the exact same way. Sodium particles want to flow from one side of a battery to the other, just like lithium particles do, which meant that in theory, you could swap one for the other and the battery would still work. But in practice, the problem was obvious, and it blocked everyone for decades. Sodium particles are bigger than lithium particles, and that changes everything about how the battery performs. Think of it like packing a suitcase. If you are packing small tennis balls, you can fit dozens of them into the same bag, and that is lithium. Now try packing softballs instead, and you fill up the suitcase much faster while fitting far fewer in, and that is sodium. A sodium battery the same size as a lithium battery simply holds less power. For a phone, where every tiny bit of space matters, or for a car, where driving range is everything, that gap was a deal breaker. Sodium stayed on the shelf as the backup option, the second choice, the maybe someday technology that never earned its shot. And that is exactly what makes the next part of this story so surprising. Because what China just pulled off is the part that has American energy officials scrambling to catch up. Here is what happened, and this is the part that matters more than anything else in this video, so stay with me. The problem always lived inside the battery, specifically on one side of it. Remember, a battery has two sides, one that pushes particles out and one that catches them. The catching side is where everything fell apart for sodium. Old sodium batteries used a catching material that worked like a sponge full of big, loose holes. It could grab sodium particles, but a huge amount of the space inside that sponge sat empty, doing nothing useful at all. Think of it like a parking garage where half the spaces are too narrow for your car. You drive around and around looking for a spot, but most of them are useless, which means you end up parking far fewer cars than the building should hold. What the Chinese engineering team did was tear up that parking garage and redesign it from the ground up. They built a new catching material where every single space is the exact right size for a sodium particle. No wasted room, no empty gaps, and every tiny pocket doing useful work. That is not a minor tweak or a small improvement. That is a complete rethink of how the inside of the battery operates. And the numbers back up every bit of it. The new sodium batteries rolling out of Chinese factories are now hitting energy levels that land close to the lower end of lithium batteries. They are not equal yet, but they are close enough that for most everyday uses, you would not feel the difference in your hand or behind the wheel. Let that sit for a second. A battery built from salt, the same stuff you sprinkle on scrambled eggs, now performs nearly as well as a battery built from one of the most fought-over metals on the planet. And this is where the whole equation flips on its head. The sodium in these batteries costs almost nothing, with the raw material price sitting at roughly 1 to 2% of what lithium costs. A few dollars worth of sodium can do the same job that hundreds of dollars worth of lithium used to handle, which means that even if the sodium battery holds slightly less power, you simply make it a little bigger, and the total cost still comes in at half or less of what a lithium pack runs. That is not a small upgrade, that is a completely different set of numbers on every spreadsheet in every car company boardroom on Earth. But the battery itself is only half of this story, because what happened next is what sent shockwaves through every government and every company that depends on battery power. China did not just figure this out in a lab and publish a paper about it. What nobody expected was that they would skip straight to building the factory, and they built it fast. CATL, the biggest battery company on the planet, started mass-producing sodium batteries at full factory scale, not in small test batches, not as a side project, but inside a building the size of 40 football fields, pumping out sodium batteries by the millions. And they are not the only ones moving. BYD, the Chinese car company that recently passed Volkswagen in global vehicle sales, started putting sodium batteries into real cars that real people are buying and driving on real roads today. Not concept cars and not prototypes, but vehicles you can walk into a dealership and purchase right now. On top of that, at least 5 other major Chinese battery companies announced their own sodium production lines over the past year. The race kicked off before most of the world even realized it was happening. And this is where it gets worse for America. The United States spent the last few years trying to build its own battery supply chain from scratch, pouring billions of dollars in government money into tax breaks, new factories, and mining projects. The whole idea was to stop depending on China for lithium batteries, and that plan was making slow but real progress. But then China changed the rules of the game entirely, because sodium is not lithium. You do not need special mines for sodium. You do not need the same factories, and you do not need the same supply chain. All of that money America invested in building a lithium battery industry still holds some value, but it is now aimed at a target that just moved. It is like spending 5 years training for a boxing match, and then your opponent shows up and announces that you are playing tennis now. South Korea caught on quickly. Samsung and LG, 2 of the biggest battery makers outside of China, both launched sodium battery research programs in the past year. Japan moved too, with Panasonic filing a wave of patents tied to sodium battery designs. Over in Europe, a French company called Tiamat started building sodium batteries aimed at power grid storage. And even in the United States, a startup called Natron Energy opened what it calls the first sodium-ion battery factory in North America. But here is the gap that should concern you if you are American or European. China is not researching sodium batteries anymore. China is already selling them. Everyone else is still running lab tests while China operates in the open market. And in technology, the company that ships a product first almost always wins, because real customers generate real feedback that drives faster improvement than any test lab ever could. One energy analyst put it bluntly when speaking to reporters. Companies are not chasing sodium batteries because the idea sounds exciting. They are chasing them because building your entire energy future on a material that only comes from 3 countries carries a risk they can no longer afford to take. And the fact that sodium exists everywhere changes the politics of energy in a way lithium never could. Right now, if your country wants to build electric cars or store solar power, you need lithium. And to get lithium, you need to buy it from Australia, Chile, or China. That hands those countries enormous power over your energy plans. Sodium flips that arrangement completely. Every country has sodium. Every coast touches an ocean full of it. And you do not need a special mine or a trade deal to get it. You just need the technology to build the battery, and that technology is spreading fast. But none of that matters if it does not work outside of a factory, because there is a real difference between a product on paper and a product that survives 10 years of daily use. And that is where this story faces its most honest test. In early 2025, the Chinese car company Chery launched a small electric car called the iCar, carrying a sodium-ion battery pack inside. It pulls about 250 kilometers on a single charge, which works out to around 155 miles. That number is not going to win any road trip contests, but think about how you actually drive on a normal day. Most people cover fewer than 40 miles between their morning commute and their evening errands, which means for getting to work, picking up groceries, and dropping off kids, this car handles the job without breaking a sweat. And the price tag comes in thousands of dollars below a similar car running a lithium battery. Thousands of these vehicles are already on roads across China right now, owned by regular people and charged at public stations. Early data collected from hundreds of charge cycles shows the batteries holding up well, even in cold weather, which used to rank as sodium's single biggest weakness. That is not a lab result, and it is not a slide from a corporate presentation. That is a real car with a real battery driving on real roads. And so far, the numbers check out. Now, I am going to be straight with you because this story is exciting, but it is not perfect. And pretending the problems do not exist would not be honest. The energy gap still stands. Sodium batteries perform close to lithium for everyday city driving, but for long-range trips where you need 400 miles on a single charge, lithium still wins that fight. Sodium is not replacing the highest-end Tesla battery packs anytime soon, and anyone who tells you otherwise is selling something. On top of that, the technology is still young. Lithium batteries carry 30 years of research behind them, along with billions of dollars in tiny improvements that made them better year after year. Sodium is just getting started down that same road, which means we do not yet have 10-year durability data because these batteries simply have not existed long enough to produce it. And the rest of the world's entire manufacturing system was built around lithium, from the factories to the recycling plants to the car designs themselves. Switching to a new battery type is not like updating software on your phone. It means retooling factories, retraining workers, and redesigning products from the ground up, all of which costs serious money and takes real time. But none of those problems change what the science already shows. A battery built from one of the cheapest and most common materials on the planet now works well enough to power a real car that real people are buying. The gap between sodium and lithium is real, but it is shrinking with every production cycle. And every previous generation of battery technology faced its own version of that exact same gap, and every single one eventually closed it. So let me finally answer the question this entire video has been building toward. The question of why any of this matters beyond an interesting science story. For 20 years, the world has been trying to break free from fossil fuels. And for 20 years, the same wall has blocked the path. Batteries cost too much. Solar panels dropped in price years ago. Wind turbines came down right behind them. But storing that energy for nighttime, for cloudy stretches, for the hours when the wind dies down, that part still carries a price tag that stops entire countries in their tracks. And the reason it costs so much traces straight back to lithium. Sodium does not solve every problem on that list, but it does solve the cost problem. And the cost problem is the one that has been blocking everything else from moving forward. Think about what genuinely cheap batteries would mean for your life and for the world around you. A world where every country, rich or poor, can store its own clean energy without asking permission from a lithium supplier. A world where you do not need to control a mine in Chile to build a working power grid. A world where the price of an electric car drops low enough that it stops being a luxury purchase and starts being the obvious choice for normal families. And the country that cracked this open first, the country already building the factories, already selling the cars, and already shipping the batteries, is not America. It is China. That head start is exactly why officials in Washington are nervous, because in the battery race, coming in second does not mean you finish close behind. It means you spend the next decade buying someone else's technology instead of selling your own. The world that ran on rare, expensive materials did not see its own ending coming. It just started losing ground, quietly and steadily, to something cheaper, something simpler, and something that was sitting in a salt shaker on every dinner table on the planet the entire time. If you made it this far, you now understand something that most people will not hear about for another 2 or 3 years. Hit subscribe so you do not miss what comes next. And here is what I want to know from you. If a battery made from table salt can go head-to-head with lithium, what other cheap, everyday material do you think could be hiding the next billion-dollar breakthrough? And drop your answer in the comments because I genuinely want to read them. I will see you in the next one.